Welcome to my day 15 of experiment on learning fluent English. Today I will discuss about CAP theorem. CAP theorem is one of the most fundamental basics in distributed system. It is guiding principle for the engineers to design a reliable and a scalable databases. This CAP theorem guarantees three core components, that is consistency, availability and partition tolerance. So this method, this theorem states that in a distributed system, two of the three guarantees of this theorem will definitely be there at a given time during some network failure. We have to have two of any of the three. Let's start with consistency. So consistency is for all of your read request, you will receive the most recent write or an error. So here whenever there is a node which is not able to get connected to a main cluster, there is a network failure, you will have either an error or a more recent write. So basically this system can be considered as a unified single unified database. Now second is availability. In availability, all of your read request will receive a write which is possible, it is not up to date. Basically you will not receive an exception, you will not receive an error or a timeout, you will definitely receive a read, and again which could be outdated, which is not the latest version of it. Now I will explain it why. Now third is partition tolerance. So partition basically is a communication failure or a network failure, and partition tolerance is a capability to handle this failure even when the network is down, even when the communication is totally broke down. Having a capability that our system is still up is known as partition tolerance. Now generally in a real world scenarios, our networks are prone to failure. It is a distributed system and network failure is definitely going to happen, especially this time we are seeing the outages and all this year. So option 1 is consistent and partition tolerant. Option 2 is availability and partition tolerant. Let's start with option 1. Whenever there is a network failure, availability will be sacrificed because consistency had to be maintained. So basically for your read, you will definitely get the latest updated data. If there is a network failure, you will receive an error, you will not be able to send any read or write request, nothing. Example of this is our banking ledgers or banking systems, where consistency is highly crucial. So if their network is down, they will not show you any inconsistent data or any old data. You will simply get that okay, error is there, you will not be able to make any request. Now let's talk about option 2, which is availability and partition tolerance. So when network error occurs, here consistency is sacrificed. Basically here I'll say that you will definitely receive any data which could be outdated and it is not a newer version of data basically, or you will not receive an error, and you will not receive any error, you will not see any timeout here. Sorry, I got stuck here. Okay. So basic example of this is video streaming platforms or our social media. For them it is important that their application or web application is definitely up all the time. Even though the user is seeing some outdated data, it is not an issue. If some users are seeing different data, it is not an issue. Main is they should not see that their application itself is down. Now let's talk about quick examples we can take. Relational databases like PostgreSQL or MySQL is a prime example of consistency. Their main purpose is to show the consistent data. Now, in NoSQL database, it is further categorized. Cassandra or CouchDB is an example of availability and a partition tolerance. So they can guarantee the massive scaling and failure gracefully, but they will not have the consistent data all across the node. Basically, it will be eventually consistent. And second is MongoDB. MongoDB is an example of NoSQL database for maintaining the consistency. They are very good at this. And now, concluding all of this, this CAP theorem suggests while designing our application, there is always be a trade-off. There is nothing like what is great, like consistency is great or availability is great. As per our requirement, we need to decide which will be the good method for us. And at the same application for particular component, there could be consistency far more important than availability and vice versa. Thank you. If you like it, please like the video, subscribe and support me on it. And I will get better with time. Thank you.